Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to do another code review for you. And basically, what I did yesterday was I did a code review on the Titanic, which was a binary classification. And what I'm going to do this morning is I'm going to do a code review on a regression. And so we're going to use California house prices as the data set for the regression. And so basically, we're going to be using TensorFlow because I'm studying TensorFlow now. I think I studied sklearn as much as I could study sklearn, and it was, to be quite honest, it was starting to get a little bit boring. And so now I'm on TensorFlow, and so now I'm going to study TensorFlow, study as much of TensorFlow as I possibly can, do as many models in TensorFlow as I possibly can, to try to learn TensorFlow and to make code reviews on TensorFlow and to make blog posts on TensorFlow. So this is what we're doing in this particular video. So I created this program in Google Colab, which is a free online Jupyter notebook. It's a free online Jupyter notebook that is hosted by Google, and it's a great platform. There are some things that it can't do. It's used mainly for data scientists, but the only bad thing about it is it doesn't have a very good undo function, so you have to be careful not to overwrite or delete code. If you overwrite or delete code, you may be able to go into the save history and retrieve it, but that's not always the case. So the best thing to do is just try not to do it. So after I created my program, I imported the libraries, and the libraries that I initially imported were Pandas as PD, which is for data processing, and I imported NumPy as NP, which is for numeric computing. I imported matplotlib.pyplot as PLT, which is for data visualization, and I imported Seaborn as SNS for data visualization as well. I also may have imported some sklearn, which is for machine learning, and then I definitely imported Keras Tensorflow, but that's on down the line. So after I imported my libraries, I loaded the files, and the great thing about Google Colab is they give you some test files to use. So the California housing is actually in Google Colab in the sample files, so it's there in Google Colab, so you should be able to get it on your Google Colab as well. So I used Pandas to read the files and convert them to data frames, and so they were train and test data frames. So you can see the train file, which is 17,000 rows by 9 columns. And the median house value is your label or your target. And you can see the test file, which is 3,000 rows by 9 columns. So what I did was I took the combi and the train, well, I took test and appended it to train, and then so you had 20,000 rows by 9 columns. So we checked the information on the data set, and you can see all of the features or columns are floats, so that's good. So we didn't have to encode anything, and we didn't have to convert anything to a numeric column. We checked for null values. We had 0 null values, so that's good. So we didn't have to impute any null values either. We didn't have to deal with any null values. Performed a graphical analysis. So this is a disk plot on median house values, and you can see it's definitely not a normal distribution. I did a value count on medium house value, and I could see that quite a few of the values appeared only once. So I decided to drop those rows where the values appeared only once, because they're not going to add anything meaningful to the predictions, because if you've only got something one time, then the model is not going to have anything to compare it to. So I just dropped it. And then this is how we dropped it. This is the code that we used to drop it. And so we've got 19256. Oh, let's just say I did make a mistake, so it's a good thing that let's run it again. So I did make a mistake, which is a good reason why I do these code reviews, because when I go do the code review, I can go over the code, and then if I have made a mistake, then hopefully I'll pick it up in the code review. So that's good. So we're just waiting for it to run right now. So it's doing something. We just got to give it a chance to work. Yeah, it's doing something. Finally, my computer has gotten a bit slow. So here we go. Here's our comp base. So our analysis just looks a little bit different from the first one after we removed those rows that appeared only once. It looks slightly different. And then, so that was the mistake that I made. I didn't make combi filtered, but now we say combi equals filtered, and then you can see combi. So there we go. And so what we've done is we've removed all of the rows that appear only once. And then we've got a future warning here about displot. So we can take this and this is what you're supposed to use now. So that's what we're supposed to use now. So what we've done is while that's turning away, we performed a heat map. I created a heat map. So you can see that when I created the heat map, some of the columns are highly correlated. And since some of the columns are highly correlated, then that would theoretically put noise into the system. So in normal situations, so here's the core as well, so you can see how each column is correlated to the other column. And normal situation, I would remove the columns that have a high correlation, but since one of the columns that I tried to remove was the latitude or the longitude, what I did was I just put 0.99 in here, so all of the columns stayed in place. But if you did in fact want to remove a column, then that would be 0.95 instead of 0.99. But what happened was, I think it wanted to remove the latitude and the longitude, and I didn't want to do that because I wanted to have my math in place. So now what we do is we have a scatter plot, and so we take the median income and we compare it against the median house value. So you can see the scatter plot, how the median income relates to the median house value. And then we take a box plot and we say median house age, and you can see how the age of the house relates to the house value as well. And then I created a map, and that's why I didn't want to remove any of the columns, because I liked seeing the map here. We've got another warning. It said the size parameter has been renamed to height. Please update your code. So, H-E-I-G-H-T. So we'll change that to height. And see, that's another problem with these computer programs, because they're always updating the computer programs, and then when they update the computer programs, then code becomes deprecated and you have to change it. Now I've defined my X and my Y values, and my Y value is combi median house values dot values, and my X value is combi dot drop median house value axis equals 1. And then what we do is we say feature len equals len X columns, and so feature len equals 8. So then we normalize our combi, and so X equals X minus X min over X max minus X min, and then what we do there is we convert all of the cells to a value between 0 and 1, and when we do that, the values are close together, and it's easier for the model to train, fit, and make predictions on data that's close together than it is for data that's got large distances away. And so that's why we normalize our data. So now what we do is we split X for training and validating, or training and testing, using sklearn's train test split. So the train size is 90% and the test size is 1%, and random state is 1. So you can see that we've got 17,330 rows by 8 columns for X train, and 1926 rows by 8 columns for X val, and 17,330 for Y train, and 1926 for Y val. And so now we come up to Keras Tensorflow. Keras is now part of TensorFlow as of version 2. So from Keras.models import sequential, from Keras.layers import dense. And so I found this code somewhere on the internet. Model equals sequential, model.add dense 500, input dim equals feature len, activation equals reclu, model.add dense 100, activation equals reclu, model.add dense 50, activation equals reclu, model.add dense is 1, and then we do a model summary. And so this just gives you a summary of the model. So it gives you 500 columns, 100 columns, 50 columns, and then 1 column. And it tells you what the params are. So now what we do is we compile our model. So model.compile, loss equals mean squared error, optimizer equals atom, matrix equals mean squared error, and then we fit the model fit X train, Y train, epochs equals 50. I gave it 50 epochs. So now what we do is we predict on the model. ypred equals model.predict xval, ypred, and then we filter ypred, ypred less than 0 equals 0, and ypred equals ypred.s type int. Now we check noise. The noise is 64242, and we put it on a scatter plot, and you can see there's the scatter plot. And now we compare the actual values to the predicted values so you can see what they look like. And now we use sklearn to compare the predictions. So we're comparing Keras Tensorflow to sklearn. So in this one we use linear regression. Model equals linear regression, fit x-train, y-train, and then the accuracy is 63%, and then we predict on the validation set. Accuracy is 57.6%. Root mean square is 67934, and we compare. And then here we have the a visualization of it, what it looks like visually, and then we compare the actual values to the predicted values, so you can look at that and see what it is. But what's interesting, because in regression problems, what you're going to do is you're going to look at the RMS, root mean squared error. So on the linear regression, it's 67934, and on Keras Tensorflow, it's 64242. So the error in Tensorflow, Keras Tensorflow, is less than the error than linear regression, sklearn. So that means in this instance that Keras Tensorflow outperformed sklearn. So we'll look at the So now what we've done is we've made the corrections on the code, and so you can see the corrections that we made on the code with the warnings that we've been given. And and that's it really. So we've gone through the code review. We've showed you how I pre-processed the data. We have corrected the deprecated code to put more current code in there. And we made predictions using Keras Tensorflow, and then we made predictions using linear regression with sklearn, and we have seen that Keras Tensorflow has less error than linear regression's sklearn. So that means that Keras Tensorflow did a better job in this particular instance. And that's another thing that when I was reading or watching videos or something, it said that normally these coding competitions, it's neural networks that normally win the competitions, although random forest does well. Random forest, although we didn't use random forest in this instance, but random forest performs well, but it's normally the neural networks that win the competitions. So I personally am not really planning on winning a competition for money, especially with Kaggle, and the reason why is because with the Kaggle competition, you have to be in the United States to pick up the prize, and I'm not in the United States. But I do like to enter competitions that where you don't win money. So, and then I write about what I've done. So, yeah, TensorFlow is more popular than sklearn, which I found that out. And so, yeah, so we're going to be doing more work with TensorFlow now because I've done as much with sklearn as I can. And so now it's time for me to move on to something else. And so now I'm working on TensorFlow. And then I'm going to do as much with TensorFlow as I possibly can. And we'll just take it from there, see what happens from there. So I would like to thank all of my subscribers for supporting my channel. Thank you very much for watching my video. If you like my video, please like, subscribe, and share. And I look forward to making more code reviews and videos for you in the future.